is Mark here, and I don't think that I have the luxury of somebody introducing me. No such luxury today. No, we have not started, Mohammed. No, we're starting right now. Unless, Sharon, you want to say something about this, then that would be great. But if not, then I'll just start. I'll start by giving you the screen. Here it is. So I'll go back to our chat and ask you, are we all good to start? Here's the chat. Are you all guys? Okay, excellent. Thank you so much. So that's not what I want to show in the book, but something else, this here. And I won't be all that formal. Now, some Polish there will be, and I'll be showing you the slides. But I will also give you a view into kind of a lab. You know that on Google, you can find, on YouTube, you can find, let me see. On YouTube, there are what's called Google search qualities. Let's see, Google search quality meeting. Okay, that maybe not everybody knows that such things exist, but it's a real thing. They all collect themselves, they all listen. As you can see, they check about what's going on, so you can watch what they're doing. Well, that's kind of what I want to do. I want to show you our slides, but I also want to show you what is it we do and how we come to do this. So here is the slide deck. And I will even share some of my personal story. But first of all, here is the slide deck. I hope you can see it perfectly well. And this is called Cloud Essentials. The way I came to know about this is because Optum, which is one of the 5 biggest companies in the States, they asked us to write this course, but we're also the writers and the owners. So that worked well because I think that I learned from them probably more than they taught them. And we are a company of about 10 people. We teach, we travel, we go around the world, we do it. But that knowledge, this Cloud Essentials, with all the polishes that they have, to me, they are probably one of the top software houses in the world. You know that Microsoft president, he says, every business is a software business. Of course, granted, he makes tools for that software business, but in any case, so they are a software house, even though technically they are a group of health insurance companies. And so they tell us, this is how you write software today. They call it cloud-enabled apps. At the very end, I'll show you how I'm creating a new such cloud-enabled app application and that what it will do. So I'll give you a practical lesson. But the first thing is that today there is a way to put your application in the right shape. It used to be, and I'll start typing, it used to be that your application was an application, right? So I'll say whatever application if there is, let us say maybe I'm writing well, it's a tax season, right? So maybe it is a tax application, okay? So how would you do it normally? Well, you write a program. That program you probably write in, let's say, C++. And in the old days and today, maybe you would use Java, Scala, Python, maybe. And you want to make sure it scales. Now, of course, it doesn't scale and it crashes because you're out of memory. So the next step that you do, the slides, yes. At least some of the slides, yes. Yes. And for that, I'll ask you just to do one thing. Write to us. And if you don't mind, Give us the phone. I'll tell you why the phone. It's because sometimes we like to call you and ask, so how did you like this? What else would you like to hear about? That's what we really want. Not selling out training, honestly, just because it's not right to do, but to get your opinion on this. So if you do this, that will be even better. Okay, so initially you write an application and then it crashes, and that was the story of Amazon. That's how it happened to them. And then you write a distributed application. So your next step is this. You write a distributed application, and you probably have a web-based application, and you probably have something that is scalable. And the way you make it scalable is probably by putting a load balancer, right? And a database in the backend. Okay, well, then you discover a few things. You discover that your computers crash, the load balancer crashes, the database, nobody took the backup, and you discover the real life problems. And you think, well, this is real life. There is no way that I can improve that. Well, it turns out, no. It turns out that for some people it's obvious. I've seen some of the companies that already know all of that, what I'm going to talk about. But for many people, it is not obvious. And these not obvious things were very nicely summarized by people in this paper called 12-factor methodology. So let me do this. Let me first go to the next slide. And this next slide, that's our course, so it doesn't really matter. But what does matter is what I started describing. I described that it used to be that people built it in this way, client mainframe, client server, but then they went into the more layers, and now they discovered that they need to organize all of that. So they understood that they need to completely rebuild their apps, and they needed to break them up. So if your app previously was doing everything, now you need to break it up into individual pieces. Here, each individual piece is called a microservice. And from now on, I'm talking about the real stuff. That's exactly how people build those apps today. So please ask questions. That means that from now on, I'm saying something new potentially to you, and therefore it's good time to tell me, oh, that is interesting, but tell me something about this or that. So people break up their applications into many different parts. Let us say you're building a text application. So what would you suggest as a microservice? Well, there probably should be a database somewhere, and it should be a completely separate thing, but now you see it's a microservice database. And what does it mean? That it is a separate team that's responsible for that it goes on its own development cycle. It's not hardwired into your application. It's a service, discoverable service in your network or in the cloud. But cloud is the most confusing term. When I say cloud, many people think, oh, it's either Amazon or it is Microsoft Azure or it is Google. No, what I mean for cloud-enabled apps, I mean any kind of network where I have multiple servers. That's my cloud, something that is scalable. So I will be deploying in my imaginary application, tax application, I will be deploying a database as a separate thing. Another one will probably be the expert service that knows about taxes. And there are two kinds of such thing. One is, what are the tax rules? So that will be, I give it all of the data, it comes back with what does it mean for taxes. Another, and that's AI later on, tax questions, answers. Okay, that would be another microservice. In other words, you bring your application together and then you break it down into components. Each component is called a microservice. And that's the first high level approach. So if we click further, we see that these are the advantages of what you do. You break them into microservice that's right in the middle, and microservices are defined as a collection of services. So as you see, I created 3 of them, the database part, and maybe there will be a SQL and another NoSQL part, 2 different microservices. And then the next step is tax rules and maybe even an AI component. That's right here in the middle. At the top, I need to do this. I need to scale each one of these components separately. For example, maybe the load on the database is not all that high. So one component is okay there for now, but maybe the tax rules is the highest load. So for tax rules, I want to say, could you scale this component? Could you beef it up so that it is much, much more performing? And that means that it gets better performance, that's right here in the middle, then it's never down, especially today. Can you imagine what it is, the 13th, right? And everybody's filing their taxes and it goes down. That would be quite bad, and such examples are known. So it turns out that you need to run a lot of different servers, right? Maybe thousands of servers in the back, and that should be manageable. So is there a technology? Is there technology for scalability? Yeah. So it turns out that yes, that technology is called Kubernetes or something similar to it. And to go a little bit deeper, Kubernetes is a technology that allows you to have a few different applications, and Kubernetes takes care of scalability. For example, you're saying, if my CPU is above, let's say, 50%, then start more instances. That is something that many clouds will provide you. For example, Amazon Cloud will give you that, and the same thing goes for Google and Microsoft. But you can do it on your own. You don't really need one of those public clouds. The next question that will come up is this. Every developer now works on each individual microservice. And so there are developers who do the tax analysis rules. That's a separate group. They're doing their own stuff, and they give you the application, and the application crashes because what they used was maybe Windows, let us say, maybe Mac, where you deploy it is Ubuntu, and it doesn't work. So that brings up another question. Deployment. Is there today, is there a good application that allows you to deploy without any problems? Well, it turns out that the answer is yes. And there is an application called Docker, and that application allows you to deploy flawlessly. How does it do that? So I'll tell you, instead of asking how many people have heard about Docker, I'll just tell you what Docker is in a couple words, and we'll just continue. So what Docker is a lightweight virtual machine. Let us say I want you to have an application, and I don't want you to worry about does it install on my version of Windows or it does not. So instead, I give you a virtual machine, which you download and run it, and it surely works because I'm not running it on your Windows. I'm running it on a virtual machine, let us say VirtualBox. Okay. So that's a good way. I'll send you 1,000, or you will copy 1,000 times. You run up 1,000 those virtual boxes, and that will be Docker organizing your virtual boxes. The only problem is that VirtualBox is an overkill. It's just too slow. It's a whole thing that I'm shipping you. I'm giving you Linux, which you don't need. You have your own Linux with a lot of stuff. So people invented something else. They invented Docker. Docker runs in Linux, but it only runs your application. So Docker is, let's take the most important part of my application, the application itself, package it for Docker, just like you would package it for a virtual machine, and you run it there. So now we see the modern approach. The modern approach is you take your application, you break it into individual components, you give each individual component to a team. And then you tell them, guys, whenever you have a new release, then package it into a Docker. And that way, It will always run in any environment. And then when they ask you, well, I want a few of my applications running at the same time, you're telling them that's okay. You give me one application, I will be the one to organize it inside of a Kubernetes, for example. There are other specific components. For example, you don't have to use Kubernetes, you can use Swarm. But the idea is the same. And that idea is basically represented on this slide. So what I'm saying is that I'll take my existing application, which is current situation with the tax service. I would imagine they're not on that level as yet. If they are, please correct me, I'll be happy to know. And then instead of that bottom part, we change it all, we break it up. Nothing of that is very, very simple, because you can break it into very small components and it will be tedious and not really great, or very large components and that won't be working well either. So when you're doing those microservices shown here, you need to have the right size, and for that you really need smart architects. But once that is done, then you put it into what is called cloud native applications, and they do this. What I showed you here is one particular way of implementing it, and here I was mentioning specific technologies. But all of that together is summarized in a specific paper, which if you know, then great, and you know it. And if you don't know, then I'll give you the link right now. So we'll go into 12-factor apps here. So what is that? This is something that was written by guys who started this movement of going into cloud-enabled apps. And they said that whenever you're building a new modern age application, then these are the things that people don't quite get, don't quite understand. And here are the 12 factors. Now, it used to be, here they are. It used to be that design patterns was all. You may have heard about this. Design patterns, and there was pattern like a singleton, a pattern like a facade, and so on. Well, that's a long time ago. By now, all of these were small components within your software. These are the larger components. That's a complete list of what you need to think about as an enterprise, be it Google, Facebook, or a small software house. And let me just briefly cover some of them so that you get a good idea of how that list is organized. Then we'll go back to the slides. So number one, principle number one, it says that you should use a code revision system, code tracking system, which of course probably everybody does, and that's probably some kind of Git. But in any case, what that says is that you should have very universal code base so that everything can be now automated. The code is in one place and everybody in the enterprise can do this. For example, Google, they have 2 billion lines. That's amazing, by the way, 2 billion lines of code all stored in one place. And if you want to build the whole thing of Google, you can. They have, of course, a special build system for that. The next step is nothing should be implicit. It's not that, oh, I thought you installed it on your computer. No, it should be always saying, we need that dependency, because that's one of the principles that I should be able to rebuild it in my environment and it should still work. Now, you may notice that this is a little bit higher than what I was talking about. I only mentioned, I didn't say anything about the code bases yet. And as far as dependencies, here, well, really, that's implemented in Kubernetes and Docker. But on a higher level, you don't have to use specific Kubernetes or Docker. You do have to have specifications for all dependencies so that now I can rebuild all of the software in your enterprise in my environment. And then other things like you have the configuration service, which means that somewhere there is a complete configuration and nothing is in the checklist of the administrator, but it is somewhere for automation. I'll give just a couple more. Backend service, that means that my database, the one that I was adding to my text service, that database was a separate special component. And what I gain by this is that I never have to do my local storages or session. If a person logs in and he files his taxes, then there is a backend service on the backend, and I don't do the wrong pattern of storing his current temporary state of the tax return, storing it on my server, because if my server fails, he loses his tax return. That's the idea of a backend service, which translates in modern terms into you never save the state. It's an anti-pattern to store the state in anything but a separate resource. And one more: build, release, run. This is also often spelled as continuous integration, continuous delivery, CI/CD, which means that anytime your developer pushes his code into a repository, that causes a rebuild of the whole system. So if his change breaks anything, then he knows right away. Or it also runs a complete test. So it doesn't just break the code, but it also breaks the performance. Well, now, not everybody does it, and I didn't really mean that on every commit you have to do it. That is a policy. Today, the statistics is probably maybe 20% of all of the people who really do complete CI/CD. But the idea, at least you see that here, is that you should strive for that. So we get these building blocks, which assure you that you are going in the right way, that you know that your code is always tested. You don't feel nervous every evening that what if somebody wrote something wrongly, because you know there is an automatic test for that. I'll do just one more: port binding. That is a very simple idea. It's much, much less than all of the previous ones. But port binding means that every one of those microservices that I give you, I expose on a certain URL and with a certain port. And therefore, if you expose this particular service, like a database, on a certain port, then everybody knows where to find it. And another service will be on another port. So it's a very simple idea that you don't fix anything, you don't fix any ports, but you assume that somehow you provide your service and somebody else will be able to consume that service, and you will tell them what URL and what port. Now that's simple, but don't forget to do it. Otherwise, oh, he already took that port. What am I to do? I'm running on the same port. That shouldn't happen. Who does it? Which system in the world does it? Well, Kubernetes. Kubernetes does this for you, and you don't have to worry. And so on. So let's go back to the slides. That's now telling you how you build your applications today. Now, again, you might know all of that, but in my case, I live in Houston, Texas, and whatever new things I find out, I immediately take it to my meetup. And it's a Hadoop meetup. So the meetup is pretty big. It's about, it's not only Hadoop, it's Spark and machine learning. It's about 1,500 people there. And interestingly enough, almost no technology in Houston. It's somehow, it's a great place to get away from, because you have, let's say, Chinese embassy if you want to go to China, and Russian embassy if you want to go to Russia, and Brazilian embassy if you want to go to Brazil, but no real technology. Okay, so I take it to my meetup and I'll tell them, guys, these are the new things, and people tell me, wow, that's what I was looking for. That's what I need. Now, how do I convince my boss that that's what we need? And for that, I don't have an answer as yet. Maybe one day I'll also tell you why you need to go to this new way of how software is built, but I'll tell you who does it. So Google kind of invented this, and they also support Kubernetes. Now, an interesting piece of information is that Google does not run on Kubernetes. Some of it does, but they have another thing called Borg. If you don't know Borg, no, like this. So that's for a very, very large size, but the team that supports the internal infrastructure at Google and the one that supports Borg, it is the same team that does Kubernetes. So it is very much related, and all of the other companies that you might think about, they are probably on that. I'll give you some examples that one where I personally spoke to. So let's say Facebook, of course, the healthcare, yes. The one that I've recently done into ETS, lots of companies are already this way. And if you ask them, are you already doing this way? Then yes. But for many people, amazingly enough, and that's what my example is, my meetup, no, not yet. So that's what you are doing. And the very important next step, and probably the last real new step that I want to bring here. Now, these slides, they continue. We're talking about automation. That's the CI/CD. We're talking about breaking down the silos so that becomes one overall system. That just emphasizes that what you get in return after you do all that work is you to get what is called the cloud architecture and how that is different. But one important thing I want to talk about is that was just the software architecture. That is what is called cloud-enabled apps. That's the technical term. And again, I mentioned that people usually today, they think, oh, cloud, that's probably Amazon. It was worse. People thought, oh, cloud, that's everything that comes from the browser. That's a cloud. Just a few years ago, people really thought that. Well, now we know cloud is something that's up there, white thinking, cloud that is somehow elastic. That's the name of the Amazon, Elastic Compute Cloud. So that's that part. But the other part is AI. Okay, so if you look at your applications, that's a new story. So far, I have built dumb applications. They were not smart. They were scalable. They were not failing. They were always there, but they were not extremely intelligent. I have recently read an article. It's an interesting article, and just in case you want to read it, I'll give it to you. It's why doctors hate computers in New Yorker. Okay, so that article, and it tells me I can read two more. Okay. That article says that every time there is a new version of the software, doctors have to take 2 days to learn it, and it's so junky that they hate it. I have to say that he mentions which maker that is. There are two makers of hospital software. One is called Cerner, and the other one is called Cerner competitor. Who is that? Let's not mention that. The article mentions him anyway. Okay, and he says that, you know, that doctors hate the software because it's so bad and so stupid that they even hire assistants to walk behind them and write down what the software wants. But you could see that the problem with the software is not that the software is bad per se. Software is probably good, but that they do not use all these 12 principles, the ones that I just showed you. And that's why you get things like every little change in the software changes everything else and breaks everything else. That happens because they don't use microservices, right? And then the release cycle is slow. Well, again, that's because they update everything together and not individual pieces. But the very important thing is that no AI. Okay? Starting from the simplest, where it knows I'm logged in. So why is it asking me to log in again? Why is it asking me my name? It knows my name. To a more complicated, where it says, well, what are the common reasons for that? It should know this. And that is the revolution that's going on. That is something that Google is promoting as everybody should be using it. And Google is promoting it in a big way by giving away free training and free hardware like this. If you go to Colab, then this is the place where you can run pretty hefty machine learning for free, including GPUs. Right? So that's one way to promote it. Another way, Andrew Ng, and that's the guy who everybody probably knows because he teaches at Coursera and he's the founder of Coursera. So one of the things that Andrew is running for president, but another thing is that AI is new electricity, right? So let's see. That's where all of the Coursera offerings and why AI is new electricity. Now, his idea, and I'll give you this article, but you can look at any other article. So his idea is that just as electricity changed the world, and to check that, just turn off all of your electrical devices right now, and you will see that it's just very hard to survive that. So we're all in electricity, all of our factories are in electricity. That completely changed the world. So AI is going to change the world in exactly the same way, and all the software will be new and smart and so on. That's where he said it for the first time. It's a new electricity. Going back to our slides, that what I showed you, that was just the architecture. Now what you do with it is AI. And this AI, according to Andrew Ng, is pervasive. He says any company that's more than $500 million market cap needs to have AI in its software. And that, he says, is in fact the thing that will distinguish between have and have nots. That will be the major competitive advantage of every company. So according to Andrew, that will be everywhere. And there are many ways to learn it. What we do is we teach that around the country in many places. I just finished teaching it where American Express Phoenix. I think I'm not quite allowed to say that, but that's all right. So what was interesting is that every time we run it, it's a different class. AI is not like other things. It requires understanding. Other things, superficial, like Spark. You can learn Spark. Hadoop, you can learn Hadoop. But artificial intelligence requires a new approach with every student, every group. And then I usually give a little workshop or a hackathon, but they don't call it a hackathon because hackathon is overused. Instead, I'm saying, let's design something. Let's create a real use case for AI. And then people come up with a use case. That is the hardest thing, to think about not the technology. Technology is just trying to imitate what humans do. For example, face recognition. Well, people do face recognition, and now the computers also do face recognition. Great. But what you're supposed to do in order to participate in this AI revolution is know how to find out good use cases. And that is what will distinguish one company from another. So that is something that you will be putting into your software. This is what you put it on, but what you put it above, that's the AI. So that talks about then the 12-factor methodology and how you implement all of them. And if you want, you can go and think about what technologies will I use. So it's talking about how you build it. And let's say it's best practices. So here are those things. You can recognize it. It's exactly from the website. Then there are interesting new ideas that there are perhaps 2 or 3 more factors that they were never mentioned, and you can find these in the modern way of deploying your apps, because so far I just built it. So where do I put it? One of the new ideas of putting them somewhere is creating a platform that will allow me to just push it into something. And this push into something can be either OpenShift, or PCF, which stands for Pivotal Cloud Foundry. So quite a few providers implement this, and that's the next step. It's PaaS, that's Platform as a Service, but I don't want to go there because that's yet a new idea which I don't really want now. What I want is those 12-factor apps. Now, it doesn't mention AI. You see that. So your next step is now I want to make every application intelligent. So at this point, I'll stop this slideshow, okay? And I'll give you an example of what I'm building right now. Okay, right here, that will be a picture that I will be building, okay? And that is what I call SKAIA, which stands for Scalable AI. So I wonder, they tell me that the site is already there. Let's check. I don't know if it is. SKAIA AI, is it there or no? At least I don't see that, right? Okay, but that's not the point. We'll talk to whoever is propagating this. This is the idea. The idea is that today you get a lot of information from many different sources, and nothing is easy. They may be unreliable. You may be getting information that is not exactly perfect. All of that is real world. If you rely on the information to be perfect and on the services to be up all the time, then you will be probably in for a big surprise, right? So that's the first part, and that you recognize this part should be used in the 12 factors. That's where they will come in to make it scalable, to make it fault tolerant and all of that. But here on the right, what you put inside is the AI part. So for example, somebody may come, and that's one of the projects we're doing. There is a complete website that tells us about every person in jail. Well, for research purposes, I want to scrape that and tell me about that particular person, what was his story. That's much more of an AI task. Or let's say you're a lawyer, so you get all of the information on this case, and then you're saying, okay, I see that, I can search the emails. That's not what I want. I want to know what's the relationship between, let us say, Enron and a certain company. So these are the kinds of things that are today not quite there. It's not easy. One practical example that I'm working on right now is what is called reverse image search. That means, look at this kind of pretty bad image. It came from one of the 12 major social networks. So who squealed? What happened? That's pretty bad for publicity. Can you take that image and tell me the story? Well, that's one of those tasks that today you wouldn't even quite think what software can do it. But that's a must. That's something that you need to build. So that's what I'm building right now called Skya. That's for scalable artificial intelligence. And I'm not building it on emptiness. No, I have an open source application. This one, you see, I'm telling you absolutely everything. So it's called free. That's for lawyers. That essentially does that thing that I showed you, that what lawyers want. It does it, but it is a monolithic app. It's built on Hadoop. It's built on other open source tools. But what I want is to make a complete, scalable, 12-factor enabled app out of that, break it into microservices, and we're working on that. And then put enough AI on the right side. Well, I think that to summarize what I wanted to present you was this. I wanted to say that there is a way to create applications today, and that way is by using a 12-factor app, and the general discipline that does it, it's called a web or maybe cloud-enabled apps. That was the fact number one. And fact number two is that there is this movement that if you want your application to really stand out, then you would want them to be AI, artificial intelligence enabled. These are the major points. So please ask questions. That's the whole purpose of a live webinar rather than the recorded one, even though we probably recorded this one. What are your questions? That's the whole purpose of being here, talking here, right? So that we can try to think of new questions, new answers, and maybe even design something. Okay, so I'll give you a couple minutes to think of that. Meanwhile, please write. You can write to info@elephant.scale and all the other emails that you got while you were signing up for this webinar. And if you also add your phone, that's very nice, because in return, you'll get some of those slides. Okay. Nice. It's a very nice question. What are the AI engines that are readily available? I'll show you two, since I'm still sharing the screen. One of them is Amazon. Amazon controls 30% of the market. And they give you not only AI, but all of the other integrations. And they're trying very hard to stay on the top. but they're not growing. So 30%, that's what they had last year, and 30% today. Compare this to Microsoft 16%, Google 9%. Nevertheless, let's first look at Amazon. To get to this, you go into your Amazon console. Okay, and you log in. And the engine is called SageMaker. Here you start searching for SageMaker, that's it. Okay, now what is SageMaker? You're looking at SageMaker right now. That is a collection of services and a collection of examples. So services, they're all here, all kinds of machine learning services. These are all instances, meaning that that's projects that I run, or it's an instance of machine learning. And when you start it, then all of them are stopped right now so that we don't waste money. But if you start it, you will see about 30 to 50 examples that you can learn from how to use this engine. Theoretically, that should be very usable. Practically, you do need to learn. So that's example number one, and that is SageMaker. Example number two is, of course, Google machine learning, because that's their claim to controlling the world. So Google machine learning, not the crash course. But what I really want to show, if it comes up, good. If not, I'll show you what I mean. It's all about machine learning. So that's basically where it is. But what I would pay attention to is not just all these products. They have lots of products, probably even more than Amazon. And all these products are actually APIs. Like if you want to do vision, you don't rebuild a vision engine, but instead you use the vision engine. If you want to do text analytics, you don't rebuild the text analytics, you use theirs. But in addition, there is this Google AutoML. That's in beta right now, and that's a way to give you machine learning without knowing too much. So you will be able to automate the model selection, Google AutoML, okay? Well, everybody is working in the same areas, you know, those people, they know each other, they all compete with each other. And the funny thing, I was looking at one of the guys, and I saw, oh, he was at Chase, and then he moved to Facebook, and then he moved back to, and so on. So you see, it's a very small elite group of developers. They all develop these tools, and they all compete. They're all pretty much comparable. Now, some are better at this, some are better at that. But once you know and understand machine learning and AI as tools, then you choose your platform. People like to say, oh, that platform is much better than the other platform, that's all I'm using. It's really you. You must be much better than the other guy, and then whatever platform you use doesn't matter all that much. So did that answer your question? Was it, Praharsh, was it something that you were asking, or is it something else? Okay, that's great. And of course, Amazon has their own machine learning. And then there are libraries. But don't get confused by all of these engines. You'll find the one that you like. Mostly it's, what do I want to automate? I'll tell you what my students wanted to automate. One of them said, well, how long will it take me to get home? It's in California, long traffic. Another one said, if I hire a guy, how much he will be absent from work? Okay. Now, is there a recording of this session? I think yes. And that is something that please write to us about. Sharon, if you're here, then you can tell us if there will be a recording. But if not, then just write to us. Definitely there should be a recording, right? Are those including NLP? You're saying, are there engines that include NLP, right? That's your question. So yes, and yes, NLP as natural language processing. So first of all, you need to know something about this, and secondly, engines. So to know something about this, it's interesting that I'm teaching my first deep learning NLP course. We do teach deep learning already, but deep learning NLP is first time this coming week. So you will have to understand basically what we're doing. You need to know the terms like TF, IDF, and that is term frequency, inverse term frequency. And that gives you a way to convert your words into numbers. And from there, you need to use some kind of classifier, like logistic regression. If you know that, then you can go and use any of those engines. The Amazon engine includes text processing. Let's go there. So not on this level probably, but there must be an Amazon service for NLP. Let's see. Build text box, Amazon Comprehend, Amazon Lex. So this will be the two engines on Amazon. On Google, there will be something to do with something of NLP. Let's go there too. Right. So the best practice is to use the API. Don't sweat the small stuff. Start with the understanding of your problem. I'm trying to find the NLP. Don't get it right away, but you get things like, can you analyze my text? What is it talking about? Can you find out the major places, people, cities, dates, what are we talking about? So yes, the engines include this. Some knowledge is required from you. And then the next word is, of course, word to vec. That's an algorithm that you use today instead of TF-IDF that will make your word to number conversion even more precise. And then you use some kind of machine learning algorithm to build your classifier. So now you read your text and you're saying, oh, I understand. The guy is trying to get into a text and he's not finding it. So that is the classifier that you will later apply. Is that something that you were asking? Did I answer the right question? Mm-hmm. Great. So guys, please be in touch. Thank you for coming. It's a pleasure to talk about those things that are very, very new. I told you how I got into a conversation on an airplane yesterday and how the guy, by just looking at my screen, he said, oh, that's the deep learning book, right? So it's always a pleasure to think and talk about things. I wish you all the best and a great Friday. Hands-on official training, yes, that's very easy. You just go to our site, which is right here. And that shows you all the courses we usually teach at corporations. But if you are into one specific course, then you just write to us because we have a big public schedule. It's just that it is not on that site. It's on another one. So yes, that's true. And why would you want it? Well, there are lots of online sources. There are lots of recorded lectures. That has its place. That's definitely great. But there are also programs. We do programs. And there is also an idea that you want a session with maybe 5-6 students and you all ask questions, and that's called instructor-led training. So they almost don't compete. The people who want a lecture, it's not the same group of people who want an instructor-led training. So that's all available, yes. To me, it's a sea of knowledge today that is a kind of either free or for money, but that doesn't matter kind of thing. All right, so thanks a lot again, and wishing you all the best. Thank you.